Hey, welcome back to your favorite pre-calculus class. We're going to look at inequalities involving quadratic functions and solving those, both visually and algebraically. Let's look at this from first visually. We've got this x squared is quadratic, x squared minus 4x minus 12. And if we're looking at where is this function, so if you graph this function here, you can see it right down here, right? You've got the function there graphed. Where is it less than or equal to 0? So where is this functional value less than or equal to 0? Where are the y's less than or equal to 0? And you can see them if I outline them right down here. See how all the y's are less than or equal to. Or equal to means I'm including it because it does hit 0 at both of these zeros, right? But you got to name it in terms of the x's, right? What x values make that true? What x values make it such that it's less than or equal to 0? And so you say, well, between -2 and 6. So between -2 and 6. Do we include the -2? Yes, because it hits 0 right there, and it's less than or equal to 0. So we include the -2, so we're going to put brackets on that. Do we include the 6 as well? Yeah, because it hits 0 right there. The y value is 0. So between -2 and 6, between those x values, we are less than or equal to 0 on that. Now, let's say that we, let me erase this real quick. Let me change this just a little bit. Let's say we had instead x squared greater than or equal to 4x plus 12. Well, first you want to get a 0. You want to examine this in terms of your 0. So take these over to the other side first. So you've got the x squared minus 4x minus 12, but we've got it greater than or equal to 0. Where is this thing above the x-axis, right? Where are the y values greater than or equal to 0? You say, well, here they're greater than. You know what? I'm going to change this again. I'm sorry. Let's just make it strictly greater than. Strictly greater than. Not greater than or equal to. Only greater than. Where's this only greater than 0? You say, well, it's greater than 0 there, and it's greater than 0 right there. So at what x value does that occur? At -2. Can I include -2? No, because it hits 0, and I got to be greater than 0. So from from negative infinity up until that -2, but I cannot include the -2 because at -2 it is 0, and again, I got to be greater than 0. I got to be above it, only above it. And any x value coming from negative infinity up until the x value -2 satisfies that. And then I'm taken off again from an x value of 6. I cannot include the 6, but I keep going to the right to positive infinity. Anything x values greater than 6 from 6 and on as well. So here's my solution set for that one. When x squared minus 4x minus 12 is strictly greater than 0. When is it above, right? And you got to name it in terms of the x values there. Let's do some algebraically now. So now let's have 2x squared is less than x plus 10. The first step is you got to get one side equals 0. Okay, so subtract x, subtract 10, both sides, and we've got 2x squared minus x minus 10, and it's got to be less than 0. So what you're going to do is after you get one side equals 0, number 2, what we're going to do is we're going to find what's called the critical points. And the critical points are the zeros. Okay, so we're going to imagine this is equal to 0 for a minute. They're the zeros. And when we work with like rational functions, it'll also be where they're undefined. But right now we're just working with some quadratics. Okay, so we're just finding the zeros. So we go ahead and we factor this thing. Okay, 2x and x, that'll give us the 2x squared. Looks like it's going to be minus 5 and plus 2 will work out. And then make sure you check that. 2x squared plus 4x minus 5x minus 10. There we go. So our zeros will be if 2x minus 5 equals 0 and x plus 2 equals 0, add 5, divide by 2, divide by 2, it looks like we've got x equals 5 halves, 5 over 2. And over here, subtract 2, we've got x equals negative 2. Okay, these are our critical points. So we're going to put them on a testing interval now. So we've got negative 2 here, negative 1, 0, 1, 2, 3. And we've got this right here is where our 5 halves is as well, our 2.5 right there, 5 over 2. Okay, so these are our critical points at negative 2 and at 5 halves. We have to decide if we're going to include our critical points. So what you want to do is you want to test them into your inequality right here. Okay, so if you plug the negative 2 in, so 2 times negative 2 squared minus a negative 2 minus a 10, is that less than 0? We've got 2 times 4 is 8, 8 plus 2 minus 10, well that's 10 minus 10 is 0, less than 0, false, it is not, so negative 2 is not going to be a part of this solution. And remember, if we were to graph this, visually we're looking at the graph and we're like, this function 2x squared minus x minus 10 has got to be less than 0, it's got to be below the x-axis. Negative 2 is where it hits on the x-axis, so it's not going to be included. Same thing on the 5 halves, if you plug 5 halves in, okay, this is going to be in 0, and is 0 less than 0? No, it's not, okay? And again, that's because right here your inequality is strictly less than. If it was less than or equal to, those are going to end up being filled in and included as part of the solution. So at this point, what we want to do is, let me erase a little bit of this. You've got to now test in between those intervals, in between your critical points, okay? So what we're going to do is we're going to test something on this side of the negative 2, because we're not sure right now what the graph is doing. We haven't graphed it. We're just solving this thing algebraically. We're going to test something in between them, like 0 is a nice one to test. And we're going to test one out here. Let's test x equals 3 out here, okay? So something to the left of the critical points, something in between the critical points, and something to the right of the critical points. Okay, so if we test x equals negative 3, what we're looking for is when we plug it in, is it true or false? So 2 times 9, we got 18, plus the 3, minus the 10, so we got 21 minus 10, we got 11. Is 11 less than 0? False. So negative 3 is not going to work, nor is anything to the left of negative 2. That's what it's telling us. So what it's telling us is on the graph, this thing is going to be above the x-axis. It's not going to be less than. Okay? That's what it's telling us. That's not going to be part of the solution set. When we test x equals 0 and we plug it in, and we got 0 minus 10, we got negative 10. Is negative 10 less than 0? You bet it is. True. So all this is going to be part of our solution set in here, between negative 2 and 5 halves. Now I plug in 3, x equals 3, we plug that in, 2 times 3 squared minus 3 minus 10, we got 2 times 9, 18, 18 minus 3, 15, 15 minus 10 is 5 less than 0? False. So out here we've got a false, that's not going to be part of our solution set. So only in between here is it true, and between what x values is that? Well, between negative 2 and 5 halves. I cannot include negative 2, so I got a parenthesis on that, not a bracket. I cannot include 5 halves because it's open hole as well. I got a parenthesis on that, not a bracket. There's our solution set. Okay. Let's do another one here. Oh, here's a look at the graph. Where was this thing? What was it? 2x squared minus x minus 10. Where was this thing less than 0? You can see it right there. Anywhere between negative 2 and 5 halves, in between those x values. Okay, you see it on the graph. But you're going to want to be able to do that algebraically as well. You always want to be able to approach problems in mathematics visually or geometrically, algebraically, and analytically. Sometimes, obviously, some are better than others, but you want to have all those skill sets. It's like I want to be able to use a Phillips screwdriver is more appropriate here, even though I might be able to get the job done with a flathead or whatever. So you got to have all your tools in your tool set there, being able to use those. Here's another one: x squared plus x plus 1. Where is this thing greater than 0? And then graph the solution set. And you notice you've already got the 0 on one side. So you try and factor this thing to find your critical points. It does not factor, unfortunately, so you're stuck putting it into the quadratic formula. X equals negative b, here's 1, plus or minus square root of b squared minus 4ac all over 2a. I don't know if you guys learned it that way, but that's the way I learned it. Pop goes the weasel. Anyways, so we clean this thing up. Negative 1 plus minus the square root. Looks like we got 1 minus 4. We got negative 3 under there, all over 2. We are working. Our graphs are in the real numbers. So you notice we've got a square root of negative 3. We've got an imaginary number. So there are no critical points here. There's no critical points. So when you're graphing, okay, there's no critical points, so you just pick anything. You know, you could test x equals 0. It doesn't matter. You just test 1, and you plug it in. So we're testing x equals 0, and we just got to see if this thing is true or false. 0 squared plus 0 plus 1 greater than 0. 0 plus 1. 0 plus 1, of course, is 1. Is 1 greater than 0? True. That means on the entire domain here, it's going to be true. And so my solution set is from negative infinity to positive infinity. All real numbers. There's our solution set. Or if you want to write it with set notation, x such that x is an element of the real numbers, right? All real numbers. Okay, but most of the time you're going to be putting it like that in your homework. So here's a look at the graph on that. Where is this function x squared plus x plus 1? Where was this thing greater than 0? Everywhere. For all x's, right? For all x values that you plug in, it's going to be greater than 0. If it would have been where is x squared plus x plus 1 less than 0, and you say nowhere, this would have been no solution or empty set. Empty set on that. Okay. Thanks for listening. We'll see you guys in class.